Assalamualaikum dear students, this is lecture 8. The topic of today's lecture is modeling with classes. This is the agenda of today's lecture. What is UML? Why use standard modeling language? Essential of UML class diagram, classes, association and multiplicity, labeling associations. First we will discuss what is UML. UML is basically a unified modeling language, which is a standard graphical language for modeling, diagramming, and visualizations of object-oriented software. It was developed in the mid-1990 by three developers, James Ramba, Grady Broch, and Ever Jacobsons, each of which had developed their own notations in the early 1990s. The U in the UML stand for the unified, since its three developers combine the best feature of the languages they had each previously developed. The custodian of the UML standards is the object management group. It means that the object management groups take care of the UML. They provide standards and modifications in the UML. In 2004, the OMG approved the version of UML 2.0. UML contains a variety of diagrams, including class diagrams, which describes classes and their relationships; interaction diagram, which show the behavior of systems in terms of how objects interact with each other; state and activity diagrams, which show how systems behave; component and deployment diagrams, which show how various components of the system are arranged logically and physically. UML, however, is much more than just set of notation for drawing diagrams. It has the following interesting features. The diagram you create with it are intended to be interconnected to form a unified model. This means that when you draw a diagram with the help of UML, they provide you a combined unified model of that system. It has a detailed semantics, describe mathematically the meaning of many aspects of its notations. It has an extension mechanism which allows software designer to represent concepts that are not part of the core of UML. It is an associated textual language called object constraint language, which allow you to formally state various facts about the elements of the diagram. The objective of UML is to assist in software development. It's not a methodology because it does not describe in step-by-step way how to do things. Why use standard modeling language? Some developers have successful at developing small software system without the use of diagram or other feature of the modeling language. However, as their system become larger and larger, such developer can have increasing difficult time seeing the big picture and are liable to create poor designs and take much longer in their work. Most systems are documented with the use of diagram. These provide the structure and functionality which would be difficult to grasp by looking at code or textual description alone. In other words, diagrams provide abstractions. A model goes beyond a mere set of diagrams. A model captures an interrelated set of information about the system. A diagram is simply one view of that information. Several diagrams can present the same information in slightly different ways, either with the different notations or with the different level of details. If I can delete an element from the diagram and keep it in the model, if I delete an element from the model, it should disappear from all the diagrams. A model can let software engineers to have insight about the systems. They can analyze the model manually or with the help of some tools to discover problems and other properties of that Simple diagram generated from the model can help communicate with the clients and users. However, it's up to the modeler who make the diagram, who develop the diagram to generate these easy to understand view. Employing diagrams, a well-defined standard modeling language, adds additional advantages. Since it's a standard notation, everybody who look at the model will be able to understand, to interpret it in the same way. There is a wide variety of tools available to build UML models, and thus to enable simulations, animations, and generations of code for all or parts of the systems. Essential of UML class diagrams. Class diagram describe the data found in the software systems. As we have learned, many of the classes in these diagrams corresponds to the things in the real world. For example, in the airline reservation systems, there would be class such as flight, passenger, and airport. The main symbol used in the class diagrams are class, which represents the type of data themselves, associations, which show how instances of classes are related the instance with other classes, attributes, which are simple data found in instances, operations, which represents the functions performed by the instances, generalizations, which are used to arrange classes into inheritance hierarchies. Classes is represented as a box with the name of the class inside. The name should always be a singular and start with a capital letter. When you draw a class in the class diagram, you are saying that the system will contain a class by that name, and that when the system runs, instance of that class will be created. Optionally, the class diagram may also show the attributes and properties contained in each class. This is done by dividing the class box into 2 or 3 smaller boxes. The top box contains the class name, the next box contains the attributes, and the bottom box contains the operations. If you do not want to specify the attributes or operations, then you can simply omit those boxes and just leave the class name. The figure below shows how a class can be drawn at several different levels of details. How much detail you show depends on the phase of development and on what you wish to communicate. In the leftmost example, here we can see only the class name is shown, indicating only that the class exists. Additional detail is shown in the other 4 representations of the same rectangle class. The most detail including the types of attributes, whether the features is public denoted by plus sign or private denoted by negative sign, minus sign, and the signature of operation is shown in the rightmost example. Here we can see the every detail of that class. Association and multiplicity. Association is used to show how instances of 2 classes are related reference to each other. The association is drawn as a line between the classes. Symbols indicating multiplicity are shown at each end of the association. The multiplicity indicates how many instances of the class at this end of the association can be linked to the instance of the class at other end of the association. Figure below shows the association and their multiplicity. A multiplicity of 1 indicates that there must be exactly 1 instance linked to the object at the other end of associations. For example, there must be only 1 company associated with each employee in the figure 1. Although there is no theoretical upper bound, there is practical upper bound depends on the amount of memory and processing capacity available. If there can be either 0 or 1 object linked to the object at the other end of associations, then the multiplicity is said to be optional and denoted by 0.1 is used. So for example, figure 1 shows that there can be 0 or 1 office per employee. Here we can see it. In other words, it's optional that an employee is assigned to an office. Some may work at home or in a job that does not require an office. You can also specify the multiplicity to be interval, which is shown as a 2 dot between the lower and upper bound. Here we can see that the interval, the lower bound is 0, the upper bound is 1. The interval is shown, our range is shown as by 2 dots. The interval is also sometimes called the range. The multiplicity can be specific positive integer, and you can also specify zero multiplicity value or range separated by comma. For example, imagine that the law in some law states that the board of directors must have between 3 and 8 members. Furthermore, if the board finds itself with the insufficient members, then it can automatically dissolve and the new election must be held. During the election process, the board has 0 members. So we can see here, the board has 0 members during the election process, and when election is completed, then the boards may have the member between 3 and 8. The lower limit is 3, upper limit is 8. The range can be shown by the 2 dots between the lower limit and upper limit of that range. The multiplicity of the final example in the figure 1 should reflect these situations. There can be either 0 or between 3 and 8 persons on a board of directors. If you do not specify the simplicity of association, and then it is said to be undefined. We strongly recommend never leaving the multiplicity undefined, since much of the meaning of the class diagrams come from the multiplicity. In some earlier version of the UML, leaving a multiplicity blank meant it should be interpreted as one rather than undefined. You may see some older diagrams using this convention. Labeling associations. Association name. Each association can be labeled to make explicit the nature of associations. There are 2 types of label, association names and role name, as we can see by this example. Association name should be verb or verb phrase and is placed next to the middle of the association. One class becomes the subject and other class become the object of the verb. For example, association between employee and company is called works for. Here we can see it. You can read the association in one direction as employee work for in company. The direction to read the association is normally obvious, but can be clarified by showing a little arrow like we can see it here. Another way of labeling association is to use role name. Role name can be attached to either or both ends of associations. A role name acts in the context of association is an alternative name for class to which it is attached. For example, in the association between person and board of directors, board member is the role name which describes the people what happened to be member of the board. Here we can see the role name is board member, means the person who is a member of the board are called board member. You can read this association as board of directors. Another way of labeling association is to use role name. You can read this association as the board director has either 0 or 3 to 8 person as a board members. If you omit both the association's name and role name, then consider that association name is simply as by default. This is not very informative, but in some cases it is possible, since the meaning of associations might be clear by simply looking at the 2 classes. For example, in the association between company and board of directors, we have chosen not to add any label. The association would read as a company has a board of directors. Here we can see it. Company has board of directors. A good rule of thumb when performing analysis to add sufficient name to make the association clear and unambiguous. It is normally not necessary to add both role name and association name to the same associations. For example, we could have add a role name employer next to the company in the first association of figure 2. However, the association name works for is sufficient. We could also have chosen here to choose role name instead of association name. It's enough for today. Thank you.